All right, so let's recap everything that's going to be on the quiz so that you're not confused and that you can do well on the quiz even if I am not there today. All right, so say you got an element, beryllium, and it's going to look more like your daily check than this chart. I'm just using this chart, so it's like condensed in one little area. So here we have the element beryllium. So beryllium is here. So it's in the second column. So it already, second column means it has 2 valence electrons, right? So when you see the word valence, you're always thinking about the column number, right? So the family in the second column are your alkaline earth metals, right? So not that you have to memorize its spelling or anything, but you just have to know column 2 means alkaline earth. Okay, so if you have 2 on the outside, that's what valence means. Like on the outside, there's 2, and all elements are what really unstable except noble gases, right? So everyone's goal is to what? Look like a noble gas. So how are we going to look like a noble gas? We need either 8 on the outside, right? So let's do a quick recap of what needs to happen here. So all noble gases have 8 valence electrons. That's what makes it very stable, okay? Except helium. Helium is a noble gas, which has a total of 2 electrons, and that's it, okay? So you're either trying to look all like the noble gases or like helium, okay, if you're a really, really small atom or element, right? So you look at beryllium and you're like, okay, beryllium has 2 on the outside. So how can I look like a noble gas? Okay, I either need 8 on the outside, or if I'm small enough, then I can look like helium, right? So the whole point, remember, is to like not sit here and like draw all of them. Like some of the elements are too big for you to sit there and draw every single circle. But just to give you like an idea about beryllium, right? Beryllium has 4 protons and 4 electrons. So this one's pretty easy to draw, so I'll help you visualize it. So it has 1, 2, 3, 4, like this, okay? So 4 electrons, 4 protons. Now, how can I get this to have stability, to look like a noble gas? A lot of you instinctively want to say, we need to gain 6 electrons and then we'll have 8. But gain 6 is not going to be one of the options for you to pick, because gaining 6 is really difficult for beryllium. It takes a lot of energy that beryllium does not have. So what could it do? It's actually going to go in the opposite direction, and it can do that, right? It can lose 2 electrons. So this electron and this electron, beryllium's going to just trash it, just throw it away, like literally pop them off and just be like, see ya, I don't want you anymore, right? So let's think about what happens when beryllium does that. So if we lose 2 electrons, this electron and this electron literally gets thrown away. So what's left? What's left is this. And what did we say earlier? We said that helium has a total of 2 electrons. So what does this element look like now? It has that stability of helium now, right? It's still beryllium, but it looks on the outside, the electron looks like helium. So now it's stable. So now let's think. Okay, so instead of going always, so you're not always gaining, right? You can always lose as well. Okay, let me just give you a big hint. Like you can lose and gain like maximum 3 electrons. Okay, so if you're gaining 3, if you try to gain 3 and you're not getting to 8, then that means you have to go backwards. You have to lose it and go backwards instead. Okay, so now we learned that we're going to lose 2. So up here, you're like, okay, I'm going to lose these 2 electrons. So I have 2 on the outside, but I'm going to just throw them away, lose 2. Now, how do I correctly write this? Like, what do I write in the corner here, right, to make this make sense? So losing 2 doesn't mean that you're going to put in the corner like we're subtracting 2. That's not what that means, right? What it means is we're going to take this information right here and determine How did our atom that used to be neutral turn into an ion, which is now a charge? That means your protons and electrons are not equal anymore. They're offset, right? So what happens now is you used to have you had 4 protons, you still do, but we used to have 4 electrons, but we don't have 4 electrons anymore because we lost 2 of them. We only have 2. So what is the difference between these numbers? The question is always, what do you have more of? Do you have more protons or do you have more electrons? So out of the 2, what do you have more of? You have 4 protons, you have 2 electrons. So your answer should have been what? I have more protons. So I have more protons. So you put protons right here. How many more protons than electrons do you have? 4 versus 2 means I have 2 more. So you would see a positive 2 in the corner. That means I have 2 more protons than I do electrons. That's why it's called a cation now, because it has a positive charge, right? And as uneven protons and electrons, this beryllium now has more protons, okay? When you see this word lose electrons, right, you know you're gonna get smaller. It's like taking off clothes. You took off a big puffy jacket, you took off a sweater, you're naturally gonna get smaller. Just like you toss electrons away, you're gonna get smaller. Okay, so now let's try to speed this up. So fluorine over here is what? In the 7th column right here. So column number 7 are your halogens. Make sure you know your 4 families. And so you know that's in the 7th column. So now let's think about it. You already have 7, right? So how do we get to 8 to gain stability? Easy. All you have to do is pick up 1, right? So here, this one's really easy because you already have 7. You just need to gain 1. You pick 1 up, right? And then you get to 8. Okay, so now let's think about what are we going to write in the corner right here. This is where people mess up, is this corner number, okay? So now if we were to do like some scratch work, right? Because, you know, scratch work can be helpful here. So fluorine has 9 protons and 9 electrons. And it had 7 valence electrons, so we gained 1 to get to 8. So that means that instead of 9 electrons, we actually have 10. So now the question is, what is the difference between these numbers? And that's the charge that I'm going to give it, because protons and electrons are now uneven. So I have more what? I have more negatives. How many more negatives, more electrons do I have? 1, right? That's why you would write fluorine has a -1 charge. And sometimes you'll see it like fluorine with a -1 charge like that, but it's the same thing, right? So over here, you would write -1. You wrote the word gain here, so you know you're gonna get larger. Okay, so then next, okay, aluminum is here. So aluminum is in the 3rd column. So it has 3 valence electrons, okay? Aluminum doesn't have a family, right? It's not part of the 4 main families that we learned. So it just doesn't have one. So forget it, right? Okay, so aluminum has only 3 on the outside, right? So to gain stability, to look like a noble gas, it needs 8, right? So it's not going to gain 5. Remember, I told you the maximum it can gain or lose is 3, right? So without drawing anything, let's think. If we can only maximum gain 3, that only takes us to 6. So that's not going to get us there. That means we're going to lose 3 so that it can go to the next full shell that aluminum has. Okay, so here we're going to write that we are going to lose 3 electrons. Okay, and when we lose these 3 electrons, that changes up the charge. Okay, and if you're still like, wait, I'm confused, like, why do we lose 3 electrons, right? Then let me show you really quick, or you can skip it. So remember, it's a YouTube video. So aluminum has 13 protons and 13 electrons. So if you're confused, let's draw it out really quick, right? So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, right? So you have the 1 valence electron here, 2 valence electrons here, and 3 valence electrons there, right? The question is, how do we get to 8? And we said, hey, or I said, hey, let's lose 3 electrons. Because if you lose the 3, then where do you have 8 electrons already? You already have 8 electrons in the next, level down. So basically it's saying, hey, if we get rid of this, right? If we get rid of this electron, and this electron, then how can I gain stability? How can I gain 8? So you're basically getting rid of, right, this right here. Then how many electrons do you see on the outside? 2, 4, 6, 8. Ta-da! Right? So then we said, okay, we lost 3 electrons. So instead of 13, we only have 10. So what is the difference between these numbers? What number am I going to put in the corner of my aluminum here, right? So what do you have more of, protons or electrons? I have more protons, which are positive. How much more do I have? 3, right? So then here you would write positive 3. Here, if you wrote lose, I am going to get smaller. Okay, this last one should be easy. Krypton is here. It's in column number 8, right? So it has 8 valence electrons. Because it's in column number 8, it is a noble gas. So what is it going to do? Nothing, right? Because it already has 8. It's super stable. So it loses, gains, none. So you can write krypton has no charge because it does nothing. It does not become an ion, right? It stays neutral. The protons and electrons are going to stay equal. So that means nothing happens, okay? It basically stays the same because it already has that octet. It already has that 8 number, right? It's already stable, so it doesn't need to do anything. Okay, so these are the type of questions you're going to see in your quiz. It looks just like your daily type. I'm just going through a couple of questions. Also, the last thing I want to go through is your 2 history, guys, so you don't get it wrong. So Dmitry Mendeleev is commonly credited as being the father of the periodic table, right? Remember, he's element 101. So how did Henry Moseley and Mendeleev arrange the periodic table? Okay, so we got to remember that they both arrange them with chemical properties, right? That's why they have families, right? You have the alkali metal family, you have the halogen family. So they both did it that way. They both had certain columns that made sense. But you have to remember that Mendeleev did it first, right? And he did it by mass. Why did he do it by mass? Because he didn't even know protons and electrons existed, right? Like that was way before his time. So he did it by how heavy it was. So he could weigh them, right? So he put them in order by their weights. Okay, then later on, okay, you have Moseley. This is what we use today. He updated it because we discovered protons. Remember, protons is the atomic number. So when protons were discovered, Moseley was like, oh, this is the actual better way to organize the periodic table, which is why the periodic table is in order by the number of protons. So make sure you don't mix up those names. Mendeleev was first, the Russian guy, the creepy Russian guy, remember? And then Moseley, right? The English guy later. All right, good luck on your quiz. So you take your quiz and then make sure you watch your Edpuzzle part 2, okay, during your asynchronous time. All right, I'll see you next class. Bye.